If you had the patience to watch my last video all the way to the 20-minute mark, 20 minutes and 37 seconds, you may or may not have noticed that I made a mathematical error that should actually dramatically affect the conclusions made in the video. The mathematical error I made seems fairly simple. I put here in step 26C a minus sign instead of a plus sign, where I should have put a plus sign. However, over the last couple of days, I've been mulling this concept over in my head, believing that two ideas were compatible when in fact they are incompatible. Periodically, over the past couple of days, I have thought to myself, Self, can you remember exactly what you concluded the other day in that paper and in that video? It was C t sub b equals r sub a b over 2 times 1 over 1 minus v over c squared. Is what I concluded. But at the time, without looking at it, I was like, no, Self, I cannot quite remember what I concluded. Only that it seemed to give a mathematically meaningful answer. Perhaps you and I should go back and review to see if we can't better understand the implications of that answer. Well, upon finding this conclusion, we were both alarmed, Self and myself, at the conclusion of finding that t sub b was not a function of t sub a or t sub a prime at all, but a constant. So I pored over the steps of the derivation, and I realized that what I had done was put in this minus sign when I should have put a plus sign. But what was the result of that fix? Well, fixing that plus sign and minus sign and turning it into a plus sign, in fact, what we obtained was nonsensical. We arrived at an answer that said if v and r sub ab are non-zero, then we get 0 equal to a non-zero value. Now, what are the implications of 0 being non-zero? What we have in fact obtained is a reductio ad absurdum result. This is where you have made two mathematical assumptions that are incompatible and result in an absurd result. What does it mean? It means whereas we thought we ought to only have one simultaneity convention, that is marked here in D1, t sub b equals t sub a prime plus t sub a over 2. That is one simultaneity convention. We actually have two incompatible simultaneity convention because the other simultaneity convention is this one. T sub b minus t sub a is r sub ab over c minus v, and t sub a prime minus t sub b equals r sub ab over c plus v. So if this is our object moving by our clock b moving along at velocity v, and this is clock a moving along at velocity b, or velocity v, the time from here to here is a little bit longer because the speed of light has to catch up with the velocity. And this is a little bit shorter because the velocity of clock A is moving towards the direction that the light is coming from. So t sub a prime minus t sub b is r over c minus v. Okay, so this comes to the question, what is your natural inclination of synchronizing AB if you are AB? So let me give you two different possibilities. One is that you set your clocks. When the light reaches this point, you set t sub b equal to t sub a over r, equals r over c plus t sub a. So that is how you would set your clocks. If you were AB, you would set t sub b equals r over c plus t sub a. And then when the signal got back to t sub a prime, and you measured t sub a prime, you could confirm that t sub b was equal to t sub a prime minus r over c. Is this what you would do? Is this your natural inclination for synchronizing the clocks? Or would you look at that guy that was passing by over here because there was some guy passing by that saw your clock A and clock B moving that way. So you're going to look over at that guy and go, oh, we're going to use his velocity. We're going to say that this time is r over c plus v, and this time is r over c minus v. Now, all right, and here's what I think. His natural inclination would be to ignore that guy that is traveling by at velocity v, and he would look at things from his own point of view and assume that the speed of light was constant in both directions, because to all appearances it does appear to be that way. He would not voluntarily synchronize his clocks in this way. He simply wouldn't. It would not concern him to synchronize his clocks, to make his clock synchronized according to this guy that is going by at velocity v. He is not prevented from doing so. There's nothing preventing him from causing his clocks to appear asynchronous from his own point of view, but synchronous from the perspective of that guy that's going by at velocity v. He can, but it's not his. It wouldn't be his natural inclination to do that. And it's very important, and I'm almost thinking about going back and deleting my first video because it's just, this is too important to screw up on, to suggest that this convention of setting basically t sub b equals t sub a plus t sub a prime over 2, setting the times this time halfway between those two. That is completely, and it was measurably different. It is not, there is a measurable difference between setting your clocks, synchronizing your clocks this way using this synchronization convention, and setting your clocks this way using this synchronization convention. Now we might go further with this and say, formulate entire philosophies around these ideas to say, maybe this guy, the one that actually introduces that velocity into his equation, is actually correct. Maybe there is some master of the universe somewhere, and his velocity is the correct one, and anybody that synchronizes their clocks in using this convention is actually wrong. Maybe that in reality light does travel faster one way than the other way, and our whole perception of time and space is lopsided, so that we have one direction is, I don't know, the actual real true time and space, while we may or may not be stationary with respect to that time and space, or something like that. But there's various philosophies on this. But basically, to put it very simply, it's just two synchronization conventions. One of them uses this velocity, and the other one does not. And it's very simple. For the person who is synchronizing the clocks, it makes sense not to use the velocity. For the person that actually is watching the clocks go by, it does make sense to use the velocity. And the important point is not who is right, but the fact that they actually observe different but that they are actually different synchronization conventions, and you will obtain different readings on the clocks depending on who synchronizes them.